see if you can fit this into your window. How it maybe read, like how would this work? So this is on page 27 in our notes. And you enter it exactly the way you see it, okay? X cubed plus 0.117x squared minus 4.517x plus 40. I'm just going to take a moment to check because I don't want to get it all wrong, okay? Doesn't take long. 117, yeah, minus 4. See, also make sure you look at the powers that you put in for your x's, right? Is it x squared? Is it x? Maybe there isn't an x squared term, right? It could be that it's just not there. So you got to watch out. Okay, x represents time, and y is the height. So we know that everything we find on this graph has to do with time and height. And we know time can definitely not be a negative. Sometimes we wish, right? Oh, okay. There's something going on there. If you read this, that the height is with respect to the ground. It doesn't say height above ground. It's just the height with respect to, right? Like if the ground is 0, then positive would be above and negative would be below. Right? So let's make a note of that actually. Height with respect to the ground, right? Positive height, right? If height is positive, right, above ground, and if height is negative, it's below ground. Okay. That is with respect, right? It doesn't say above like the AC we did, right? It was above. It's just like it says explicitly it's the height above ground. Not in this case. Okay. There should have been a more of a story to this, but the idea is that the roller coaster goes down below the ground and then goes above, and then it would probably touch it one more time because there's 2 turns, right? It's either 0 turns or 2 turns, right? So I'm going to increase my window, specifically the X max. I'm going to go 150 perhaps. Yeah, that does the trick, right? So, right, leaves, goes underground, above, and then it will stop right there. Okay. Should have maybe been a bit more specific on that. So we have everything we need, right? We see the whole thing. We see the turns, the x-intercepts, the y-intercept. We're good to go. Okay. How high is the roller coaster at the start of the section of track? Well, we don't need right? We don't need our calculator for that. We know that it's 0.40, right? So we would say 40. What is it? Feet? And feet, yeah, 40 feet above ground. So we're going to be specific there. Yeah, go ahead. And then B, how long is the roller coaster below ground level? At the same time, how long is the roller coaster above ground level? Okay. So what I'm going to do here is I'm going to do a little sketch. That I work best with a bit of a visual representation, right? So we just imagine, right, we're going below it, and then we go above, and then it will stop here. Okay. So I know that if this from here to here, right, if I find that difference, right, the difference between the 2 times, that will tell me the time below ground. Okay, so let's go ahead and find that. Let's find those values first. So I make y2 equal to 0 in this case because that's my ground level. So second trace 5 for intersect. I'm going to go to this one as close as possible and then just hit enter 3 times. And that's 40.2941. Okay, so we write down 4 decimals there, 40.2941. I hope you can see that. It's a bit small, right? But that's why I say it out loud. And then second trace 5 again. Continue traveling to the next one, hit enter 3 times. And that is 12.7019. Okay? 7019. I'm going to go ahead already and find this one at the end here, okay? I'm going to find that one as well. Second trace 5. You can travel, you can jump to the red line or whatever your horizontal is and travel all the way to that intersection, hit enter 3 times. And that is 106.62. I'm going to write down 4 decimals just in case. 106.6221. So I have all the x-intercepts along this ride, and that'll probably come in handy, right? The total time till it hits the final destination. So let's do this. Time below ground. You're gonna need the space below, so just stay with me here, okay? So time below, I'm just gonna have a little title here. It's gonna be delta time, and I'm gonna grab the 40.29 ... Save yourself some space there. It's assuming we're using the 4 decimals, right? So delta time is, I'm going to give you that answer, that's 27.59 seconds. Okay, make sure you have your units there. This is the time spent below ground. Okay. And above ground, how will I do time above? Time above. You can do it the long way, or you can do it the short way. How would you do that? Yeah. That's right. Take the total traveled and just subtract this time that we just found from it. Voila, right? Everything else must be above. So yes, we'll go total minus time below. Okay, total minus time below. So we're going to go 106, 62 ... minus 2759. Are we good there? Yeah. Okay. That is a really wrong answer on my calculator here. Let's try this again. 6221 minus 27.59. Let's do that again. That's 79.03 seconds. Okay, so this is my time above ground. And I did give a clear title. And watch what I'm going to just box this in so you can kind of just tell this is two different calculations that happened there. And this is, now it's going to get even better. You ready for this? Look at that. Look at that. This is the time spent above. Okay. So there you have it. Color coded and everything. Should also try to sugarcoat it Anyways, C. What is the maximum minimum heights reached by the track? So let's do one at a time, right? So the min, we're going to go second, trace, min, and we're going to write that down. And the max, we're going to do that right here. Max, second, trace, max. You go ahead and do that with me. Doesn't hurt, right? I went for min first. It says it right up here, right? I'm calculating the minimum. So I got to go towards it. And first is you got to go to the left of it. That's the important part, right? So travel past it to the left, hit enter, past it to the right, hit enter, and there we go. And my min is 25.34, and it's negative 11.26. I'm going to write that point down and answer in a bit. Let me just go and find the max right away. Go to the left of it, then go to the right of it. And that is 81. After 81.08 seconds, you're going to reach the maximum height above of 5221. So lowest is 11.26 feet below ground. Right? Because of that negative, we answer it this way. And then the other one, the max is 52.21 feet above ground. That's the highest point you reach on this ride. Okay. D. Lots of questions, I know, but that way we can just stick to one and just work with it, right? When does the track, typo, right, reach a height of 40 feet for the first time? So glad you asked, right? We're just going to do this. I can trace intersect, right? Intersect or 5. So we're just going to find that for the first time. So I'm just going to type in 40, graph it. And it will actually happen out here. Because if you think about it, your y, oh yeah, I forgot to change that. I wanted it to be not 40, because 40 is your initial. We'll just assume that they mean this here, right? Can we change that up here in our question? Go to D for the second time. That way you're not wondering what happened, right? For the second time. So for D, change that 40 feet for the second time, because obviously you start at that height. So we'll just go ahead and find that. So I can trace 5. Oh, I'm right there. And that'll be 65.420. Put down the coordinates and then answer, right? It takes 65.42 seconds. I could ask you to say minutes and seconds, right? You take away 60, right? That's a minute, and then 5.4 seconds or 5 seconds if you round it to a whole second, to the nearest second, right? E, how long does the ride stay at or above 15 feet? This one has more work again, guys. So we know, you should know at this point that, okay, y2 is going to be 15. And then I'm just going to do a bunch of second trace intersect here. At or, what does it say? At or above? Yeah, at or above. So go ahead and do that. Y equals 15. Hit graph. So you decide how you want to do this. You decide. You're the boss here. Do you want to figure out time from here to here, then add that time that elapsed from here to here, or let's focus on figuring out the time below just like we did before and subtract it from the total time? Okay. Well, there's actually time below is right here, and also at the end here, you're also spending some time below there. So actually, it's about the same amount of work. Okay. So what I'm going to do is time above. Okay. Let's do this here real quick, a sketch. And I'm going to go like this, and like this. And my 15 line is going to be right about there. And I'm going to focus on these points right there. So from time 0, obviously, till this point, and then from here to here, I'm going to figure out how much time went by here and how much time went by here and add those two up. Okay. So let's go ahead and find that. Second trace 5. That's a lot of work, I know that, but you have to be able to do that. Okay. Enter, enter, enter. That's 6.6240. And I'm going to fast forward here and just give you the numbers. The next one here is 49.9852. And then the next one is 103.0088. You want me to zoom in? Zoom. There you go. Free ad for Mazda right there. Okay. Just because of time, I'm going to figure it out. So we are interested, right? Let's make sure we understand that. We're interested in this, and we're interested in the time that went by here. So always above that 15 foot mark. Okay. So watch this. You ready for this? Delta time. I'm going to do it like this. 6.6240. I'm not going to ask you to do this on a test, but I'm basically subtracting, right? This minus 0. Okay, that gives me the time spent. Plus, guys, 103.0, and that keeps going, minus 49.98 ... right? So you got to take the difference between these 2 points, then take the difference between these two, and you have to add them up to find the total, right? So this is obviously 6.6240 plus, when you subtract these two, you get 53.0236. And then I'm adding them, and you get 59.65 seconds. And I did this just to practice it one more time, right? So that's your answer for E. Okay. What is F saying? How much time until the roller coaster reaches the end? Assume the ride ends when it touches the ground after reaching the highest point. We already know that answer, right? We know that it is, but I'm going to just tell you how I found it. You can't see it because I'm zoomed in. There it is. That's 106.62, right? Just like earlier in question B, I already found that. So it takes 106.62 seconds. Like, we'll just answer, make sure that that's what you write down. Graph the scenario, we'll do that in a bit. H is asking, can you read H? What does it say? Write an equation that would model a ride which would spend more time below ground. More time below ground. How would you do that? Well, I always want to base this on my original, right? Like, let's say we're looking at this one. If you were to change the y-intercept, if you would make that a 30, right? Decrease that. Remember the first lesson or so, I used the Desmos to show you, right? It would actually decrease. It would bring this whole thing down, making this point further down, right? And the further down you bring this curve, the more time would be spent below ground. Okay, so my answer would be, I will say decrease D, right? Decrease D. So I will actually just copy paste. Maybe just, I will omit some of the parts. Basically, if you just went like this, right? That would technically be enough, right? It would probably change the way how flat it is, how maybe it'll make it a little wider or so. So technically, you know what? Never mind. That was short-lived, right? Let's stick with 117x squared minus 4.517x plus 30. Right? So the D value is right here. That's what I changed. So I decreased it, and that brings it lower, or will actually make it go lower the smaller that number is. Spending more time. We have to graph this, and this is going to be in AC tomorrow. I'm going to focus on cubic for tomorrow. Okay. So a graph, right? 3 marks. It's a lot of marks that you can lose if you don't do it right. So here it is. I purposely, right? This is my time in seconds, right? And I have this is the height in feet. And I need to make sure I consider a lot of things. So 106 for sure to go in here. So 20, 40, 60, 80. No, that's not going to work. So I'm going to go with 25. 125, that works out pretty good. And my height, I look at the lowest point was negative 11. I'm going to slide it over just a bit. Negative 11, and my highest is 52. So I'm going to focus on the highest, guys. Don't focus on, right, the one it's going to take up most space, so 50. So let's see here, 10, 20, 30, 40, it's not going to work. So I'm going to go 15, 15, 30, 45, and then up here I have 60. Okay, which means I have to go the same way in the negatives. Okay, so this has a negative to it. And so I'm going to start at 0, 40. That's right about, so it's 15, right? So 7.5, this would be 37.5. So 40 would be somewhere in there. And then I'm just going to go at 12 point. See, I have lots of information here to help me. The x-intercept here is at 12.7. This would be about 12.5 right here. So 12.7 is just about there. The lowest point is at 25, almost 25, 11, negative 11. So we put that right about there. And the next x-intercept is at 40, right here where my finger is. So this would be somewhere in there. And then 106 is somewhere in here. That's my furthest x-intercept, but I will still add the max, which I have right here, which is 81, somewhere in here, 81, 52, 52 is right about there. Okay, so now, I don't know about you, but I probably usually focus a little bit more on the min and the max. I do that, like this. And then I kind of finish the tail end like this to kind of make it match, right? And don't forget your equation. I should make them 5 decimals long, should I? No, I won't do that. Oh, that's minus 4.517x plus 40. Sorry, I'm going to zoom out a bit. So scale, axes are labeled, points are where they're supposed to be, or around where they're supposed to be. The shape that definitely looks like a cubic. Like if you go V, like straight up, straight down, right, or up, down, that it has to have that curve to it. Okay, so we spent a lot of time on this example. I inserted worksheets right after this. Okay, I actually tweaked a lot of them to kind of make you work a little harder. So here it is. If you go to page 28, this goes 28 all the way to 32. Are you going to do all of them? If you're Superman or Superwoman, sure. But watch this. This is what I want you to focus on. You will notice that I go linear, like the first page is linear, just a straight line. Then you find some quadratics later on, right? You see some quadratics, and then if you keep flipping, you will see some cubic. So maybe just do one of each first. Do a linear, then do a quadratic, then do a cubic, and then you do everything in between, right? That is your task, all right? Thank you, guys.